Good morning, Dennis Daniels here, Sunday Morning Science, and we are going to do an experiment for using carbon dioxide. We're going to take we're going to take 3 centiliters of vinegar. I'm going to put it into 1 glass. Here, there's 3, and we'll do it again. There's 3, a little more, a little less, not much difference. And then we're going to take 1 ice cube. Look at the ice cube. Okay, the ice cubes are more or less identical. There's 1, there's 2, and now we're going to pour this carbon dioxide, or I'm sorry, this calcium carbonate into the glass, and then we're going to flip them both over more or less as fast as possible so that they are in balance. But right now there is carbon dioxide building up inside this glass, and there's no carbon dioxide in this glass, so it's just vinegar. Now the theory is that carbon dioxide in the atmosphere accelerates heating. So we're going to let this process go for a couple minutes and come back and show you whether or not this glass, which is full of carbon dioxide now, melts the ice faster based on a standard, using a standard fluorescent light bulb. So will the carbon dioxide melt faster than the non-carbon dioxide? That is the question. Okay. The experiment has been going for a couple seconds now, and more like a couple minutes. What you're going to notice, this is this glass here is the glass that has no carbon dioxide, or minimal carbon dioxide, because there's carbon dioxide everywhere. And this one is the one that has sodium bicarbonate and acetic acid. Both of them have acetic acid as solution. Now, what I wanted you to note is that when I tried to limit the possible influence of the heat of the glass melting the ice, so I moved the glass, and note how the ice cube sticks to the glass. Now I did that with the one that has carbon dioxide in it, and I moved the glass. The ice cube is not sticking to the ice cube, or to the glass. The ice cube is not sticking to glass, so there's something that is minimizing the surface tension of the water. Could be the carbon dioxide reaction, could be the acetic acid. Well, actually no, both have acetic acid. This has acetic acid, this has acetic acid. This one has calcium bicarbonate, which might be reducing the surface tension of the water. Okay, this is the continuation of the experiment where we have taken sodium bicarbonate and some acetic acid, otherwise known as vinegar, and put the ice cubes into a glass. This is the glass full of, well, it has a mixture of well, carbon dioxide because of the soda and the vinegar. And you can see, well, it's clear from here, there's definitely some etching on the top of the ice. And note, around the base of the glass, there's quite a bit of water escaping around the edges. So this suggests that there's definitely a change in the viscosity of the water due to the vinegar or to the sodium bicarbonate or to the carbon dioxide. Because when we look at the other ice cube, which has has vinegar, there's vinegar in there, but it has no sodium bicarbonate, so there's less carbon dioxide in here. And look at the difference. The surface tension around the glass is much higher, so the water and the vinegar are holding much tighter, as opposed to this one where the water and the vinegar are escaping around the edges, which might be affecting the melt rate. But there's definitely a difference between the glass that has no or has minimal carbon dioxide and the glass that does have carbon dioxide, which suggests a change in the viscosity of the water, certainly a change in the surface tension of the water itself. Okay, well, there is no doubt about it. This is the glass that has some carbon dioxide in it, and this is the glass that has little carbon dioxide in it, right? So this one has no sodium bicarbonate and vinegar. This one has sodium bicarbonate and vinegar, and you can see that this ice cube is definitely more melted than this one. Now, that's clear. What's curious though, and I noted this in an earlier video, is that, oh wow, the ice just moved, that the surface tension of this experiment, or of this instance, is a lot less. Whereas the surface tension here, all the water, the melting water and the vinegar have stayed inside the glass, which may be contributing to the temperature of the glass. This one is different. You can see that the vinegar and the water have escaped around the edges, and that the ice cube inside is indeed much more, well, it's definitely ice cube there. What's interesting, you can see there's some particulate matter around the base of the ice cube that could be precipitate from the sodium bicarbonate, or it could be the sodium bicarbonate itself. So, no doubt about it, in this experiment, the ice cube melted faster here than it did here. There's a number of reasons why it could have melted faster. Curiously, again, the glass with the sodium bicarbonate and the vinegar, or acetic acid, the ice cube is much more visible than in the glass that's just water and vinegar. Thank you.